Hello everyone, this is Vijayalakshmi from WinMaths. Today in this session, we are discuss the concepts of functions. Mainly in this concept, we are discussed one function, many one function and onto function. Before going to study these type of functions, just recall the definition of function and some other related wordings on functions. Here, first one is function. The main function. Here, the definition is a relation from, where a relation from f, a relation f from a non-empty set, to a non-empty set A to a non-empty set B. Non-empty set B is said to be function. If every element of set A has one and only one image in set B. Okay. The definition is here, a relation F from non-empty set A to a non-empty set B is said to be function if every element of set A has a one and only one image in B. That is main thing. Every element of set A has one and only one image in set B. Here we have to represent function f from A to B. This is the representation of the function. A function f from A to B. Here A and B are the. Here A is considered as a domain and B is the codomain. Already we discussed in the relation concept. A means domain. It means all the elements present in A are called as a domain, and all the elements which are present in set B is called as a codomain. Okay, we are now taking one diagram and understand the concept of function. Here A be the non-empty set and B be the non-empty set. A function. Okay, there is a function exist from a non-empty set A to non-empty set B. Here we have to take the elements of set A. That is, for example, A, B, C, D. And in set B, the elements 1, 2, 3, 4, 5. Here all the elements, okay, all the elements in set A are called as a domain. All the elements which are present in set A are called as a domain. Here all the elements which are present in set B are called as a codomain. Here function will be exist from F A to B. Here first element is related with 1 and second element is related with 2 and third element is related with 3 and the fourth element is related with 4. Here it is the function. Okay, here we say that it is a function. The definition says that every non-empty set A to a non-empty set B. Here every element of set A. All the elements, what are the elements? 4. that is A, B, C and D. These four elements related with one and only image. Here all the elements, okay, the codomain or these all elements are called as a image. Okay, these elements are also called as these elements are also called as image of f, because there exists a function. That's why these elements are called as a image of f. Okay, by the definition says, if every element of set A has one and only, for example, A has related with only one element 1 and B is related with element 2, C is related with 3 only and D is related with 4. Okay, hence it is a function, and these elements are called as domain, as well as these elements are also called as a free image of function under f. These elements are called as a pre-image, domains are called pre-image, and codomains are called as a image of f. The main thing that range. Here another one concept is range. What is the range? Okay, range means the elements which are present in non-empty set A are related with images in B. What are the images of A? 1, 2, 3, 4. What are the elements? Okay, the whatever the elements are related with B, those elements are called as a range. Okay, here range is 4 because A is related with 1, B related with 2, C related with 3 and D is related with 4, and these 4 elements are called as a range. That is, here we have to write the function. Here f of A is equals to, A is related with 1, that is A is equals to 1. Then f of B is equals to 2, f of C is equals to 3 and f of D is equals to 4. Okay, and that is codomain may be codomain always greater than range or equals to codomain. Okay, that therefore note that what is the note point? The note point is range is subset of codomain. Remark that range is subset of codomain. Sometimes we do not take a 5 here in this set. Okay, here range becomes 1, 2, 3, 4 and codomain is also 1, 2, 3, 4. Okay, range is always subset of the codomain. Okay, next, for our discussion, now we consider the definitions of one function, many one function and onto function. Let me discuss these functions. Now, first one is one function. Here, first one is one function. Okay, one function. First, I say definition. After that, I will explain the concept. The definition is that a function f from x tends to y is defined to be one or This function is also called as a injective function. Sometimes may also asked define the injective function in examination. Okay, if the image of distinct if the image of distinct elements of X under F are distinct, that is f of x1 is equals to f of x2 for every, this symbol represents for every x1 x2 belongs to x, such that this symbol represents such that x1 is equals to x2 for every x1 and x2 belongs to x. This is the definition of 1 function. Here simply what we say, a function f from x tends to y is defined to be 1 or injective function if image of distinct element of x under f are distinct. It means every element of domain, okay, every element of domain has the unique one and only unique element in set y. Okay, the elements has the one and only unique element. Here consider a set X, because we have taken here X and Y. Our domain should be X and range should be our domain should be X and Y be the codomain. Then there exists a relation, that is a function. Okay, a function from X to Y. Every element, that is distinct elements, has the image of distinct element under F. Every distinct element is related with distinct element, that is one and unique element. Okay, now and also I will explain while taking the example. First we have to discuss the definitions now. Then many one function. Okay, many one function. Many one function. Here the definition is also same for compared to one function. Okay, similar definition. If a function f from x tends to y, a function f from x tends to y is defined to be many one function if the image of distinct elements of x under f are distinct, otherwise not. Otherwise not. Okay, sometimes the elements are distinct, otherwise not. This is called as a many one function. Okay, now the third one, onto function. Definition of onto function. Here the onto function is that onto function definition, a function f from x tends to y is said to be a function f from x tends to y is said to be onto function, or it may called as a surjective function. Okay, it may called as a surjective onto as well as surjective if every element of y, here every element of y is the image of some elements of x under f, that is for every y belongs to set y, then there exists an element, this symbol represent there exists an element x in x, set x, such that f of x is equals to y, Here a function f from x tends to y is said to be onto if every element of x is the image of x under f. Here mainly the onto function is depends on codomain, that is here x be a set and y be a set. Then a function is said to be onto means every element of y. Okay, if every element of y has the image in x, each element has the image in x, it means onto function. In one function every image, okay, every image has the distinct element is x. From a function exists from x tends to y, it means x has the one and only unique element in y. Here onto function means every element of y has image in x. Okay, now we will consider the one function, onto function and many one function from this. Now here consider 4 types of functions. Here I will consider the 4 types of function. These are in your book. Okay, these are examples I have taken from your textbook. Now consider the function f1. Okay, f1 is onto or one function or many one function. We will check now. Here every elements, okay, a function exists from x1 to x2. Here x1 is the domain and x2 will be codomain. Okay, then a function, okay, exists a non-empty set x1 and a non-empty set x2. Here every element of, by the definition of one function, here every element, distinct element has the distinct image. 1 is related with a, 2 is related with b, 3 is related with d and 4 is related with c. By the definition we will say it is one function. Okay, it is one function because our definition says every element of domain or x1 is related with x2. 1 is related with A, 2 is related with B, 3 is related with D, and 4 is related with C. Hence it is 1 1. Hence it is 1 1. Again, we have to consider the many one function. Okay, this is many one function? No, because once it says 1 1 function, then it is not undergo many one function. Okay, then we check for onto function. It is onto? No, because we have to consider the elements of x2. Okay, that is codomain. Here every element in codomain has image, but E and F doesn't have any image in X. Hence it is not a onto function. It is clear? Now have to consider the second one. Okay, have to consider second one function. Here first 1 1 condition. Here every element, distinct element has the distinct image, or every element of first set is related with one and only unique element in B. Here 1 is related with B, 2 is also related with B. Hence it is not a 1 1 function. 3 is related with C, 4 is related with D, but it is a many one function. 1 1 function not exist, then it must be on that is many one function. 1 1 function not exist means it is many one function, because those two elements are related with B and 3 is related with C, 4 is related with D. Okay, then this is many one function, but 1 1 function not. Again, while checking onto function, every element of set x2 is related with an image. Here E and F doesn't have image in x1, hence it is not onto function. It is clear? Now then f3. Okay, consider the function f3. Here x1 and x2 are two function. X1 is domain and code. A1 is related with A, 2 is related with A, 3 is related with B, 4 is related with C. Here 1 1 function exists? No. Same reason. Here also same reason compared to second function. 1 1 not exist because 1 and 2 has the same image. Again onto function. Onto function will be exist. Okay, here every element, okay, here every element has the image in X. Here A has the image, B has the image, and C has the image. Okay, then onto function exist. Then many one function is also exist. Many one function is also exist. Then it is for function f4. Here 1 1 function, check 1 1 function, many one function, then onto function. Okay, now 1 is related with B, 2 is related with C, 3 is related with A, and 4 is related with D. Okay, by the definition of 1 1 function, every element of x1 is related with one and only unique element in x2, hence it is a 1 1 function. Many one function not. Here onto function exists? Okay, because every element of x2 has the image in x1. Onto function exists. Okay, now if many one function is not used for your examination, just have to remember the main things 1 1 and onto function. Based on one and onto function, the questions will be asked in exams. Now, then the next concept, bijective function. What is bijective function? Bijective function. What I mean by the bijective? Bi means two. Okay. Therefore, definition, a function f from x tends to y is said to be bijective if one and onto functions obeys. Okay, when we say the bijective function, if a function f from x tends to y is said to be one and onto condition, then it is bijective function. Okay, now, okay, these concepts are already discussed. Now, example. Okay, theoretically we concluded now. Okay, and in examination what we do. Okay, here consider one example. Okay, here we consider an example. Example number 7. Let A be the set of 50 students of class 10 in a school. Okay, let a function from set A to n be a function defined by f of x will be roll number of the students x. Okay, here what is the function? A function will be, okay, function will be roll number of students. Roll number of students in x. Okay, now a function means here domain. Here we have to consider a domain. What are the elements present in domain? A means already they given how much? Okay, don't know. They are not given how much. For example, we have to consider 50 students in our class. Okay, have to write from 1 to 50 roll number, 1 2 3 up to so on for 50. Sorry, they have given 50 students. Okay, the set A contain 50 students. Okay, then their roll number will be 1 2 3 4 5. Here students. Okay, then natural numbers. Okay, then natural numbers. What are the natural numbers? The number starts with 1 up to so on are called as natural numbers. 1 2 3 4 5 6 up to so on. For first student, his or her name starts with A. Okay, A's roll number 1. A second one student, her or his roll number will be 2. Similarly for up to 50 students. Okay, up to 50 students, every student has their roll number. Up to 50 students means the student has the roll number 1 to 50. After that there is no student. Okay, only the class 10th has 50 students. Then in here from a function exists A to n, here natural number contains up to so on elements or numbers. Up to this, our definition says every element of set has a image in B. Here B set will be taken as a natural number set. Therefore, it is 1 1. Because up to 50 students, distinct student has a distinct roll number. Okay. Now again, for they given not onto, if every element of natural number or every natural number has the image in A, but up to 50 we have the image, but after that we have consider after 50 the numbers does not have any roll number of the student. Okay, after 50 there is no roll number for any student, therefore it is not aunt. It is clear? I think it is clear. Now again we discuss another one example. Now the example number 8 will be, show that the function f from natural number to natural number is given by f of x is equals to 2x is 1 1 but not unto. Here domain and codomain should be natural number. We have to understand the questions. Okay, main thing that have to understand the question first. Natural number to natural number. Here in this natural number set, the numbers are starting from 1 to up to infinity, all are positive numbers, right? That is 1 2 3 4 up to so on. 1 2 3 4 up to so on. Then one thing should be remember here. Here both domain and codomain are equal. Okay, both codomain and domain are equal. It means simply the function will be 1 1 and also onto. Sometimes the function depends, okay, on these conditions. Okay, these conditions. What happens? Check now. Okay, now consider function f of x is equals to 2x. Okay, first checking 1 1 function. Okay, so first condition, for 1 1 condition, every element of, okay, whatever the elements, because all the elements of domains, x means the elements in domain. Here function f of x is equals to 2x means the elements are selected as a x are taken from the set natural number. It means taken as a domain. Okay, these, what are the elements? Whatever the elements we have taken here. Here, for example, taking x is equals to 1. F of 1 is equals to 2. Okay, so 1 is related with 2. Again, for x is equals to 2, f of 2 will be 2 into x. 2 into 2 will be 4. 2 is related with 4. Again, x is equals to 3. F of 3 will be 2 into 3, that is 6. Actually, our answer will be done here. Okay, how? Okay, it will check now. Here every element of, okay, here whatever, here every element has the image. Okay, by this condition we say not onto, because all the elements of natural number, 1 doesn't have any image, okay, 2 has the image with 1, but 3 has no image, and also okay, from writing, what we write now, the writing part should be consider f of x1 is equals to 2x1 and f of x2 is equals to 2x2. For x1, for x value we have taken x1, here 2x1, for x value we have taken x2, 2x2. By the condition of 1 function, if f of x1 is equals to f of x2, then x1 is equals to x2 for every x1 and x2 are belongs to set natural number. Here the domain should be natural number. Okay, what are the elements? Whatever the elements taken from the set elements, they have the image. Okay, we have consider here. Now it is 1 condition obeys, x1 is equals to x2, our definitions. Therefore it is 1. Then for onto function, here again consider f of x is equals to 2x. Now f of x replaced by y, because f of x is a image, that's why image is represented by y is equals to 2x. Now solve the value for x. Therefore taken 2 as here, y divided by 2 is equals to x. Therefore x is equals to y by 2. Okay, whatever the values of x, the x is taken from where? From domain, because our definition says every element of y has the image. Okay, here the second group or codomain values will be substituted as a x. Here the whatever the value we have taken, okay, y value, here the domain codomain is also contain a natural numbers, substitute y value as a 1. Okay, put y is equals to 1, then x value becomes 1 by 2. 1 by 2 is a natural number, because the value of 1 by 2 will be 0.5, hence which is not belongs to natural number set. That's why x is equals to y by 2 not belongs to natural number set. So the image of codomain doesn't have any value in first set. Okay, therefore it is not on. The elements of y by 2 is not present in domain set. The elements y by 2 is not in natural number set domain, therefore it is not onto function. It is clear? Okay, don't think too much, it's simple concept. 1 means every natural number has the image in codomain. Okay, for onto condition, here all the elements must have the image, but 1 doesn't have any image, 3 doesn't have any image. It means any odd values doesn't have image in natural number set. Therefore, it is onto not onto. Similarly, for example, again consider ninth example. Okay, consider ninth example. What is that? Okay, same question. Okay, here the question is same, but think that we are taken as a function real number to real number, then defined f of x is equals to 2x. Here natural number to natural number. Here we have to consider real number to real number. What are the real numbers? Okay, all the numbers are real numbers except imaginary. Okay, imaginary means the numbers are in the form of I. Okay, the numbers can be represented as I, or the numbers can be expressed 0 plus I, that is complex numbers. Okay, here other than complex numbers, all are real numbers. Okay, whatever the numbers we have taken. Okay, here simply consider domain and codomain. The relation exists R tends to R. Okay, the real numbers 0, it may be -1, -2, +1, 2, up to so on. It may contain √3, 2 by 3, whatever. Just for our example, now I just consider these numbers. Similarly, this is also real value domain, -1, -2, 1 and 2. Okay, here consider function. The main condition is that based on these condition we say 1 on 2. The condition that f of x is equals to 2x. Here the elements which are present in domain. Okay, the elements are real numbers. We have to substitute the real numbers, whatever we have to consider. Here f of x I will consider as a -1 here. -1, that is 2 into x value -1, that is -2. Okay, then I will consider 0. 2 into 0, 0. And I will take 1. 2 into 1, it will be 2. Okay, then here we have mapping 0. When x value becomes 0, then function f of x, okay, is 0. Then we have to take -1, then it has the value 2. Then we consider as a 1, we have value 2. Okay, it is 1 1. Clear that whatever the we have to consider the values, we get image in codomain. It means 1. Okay, then we prove theoretically. Let consider f of x1 is equals to 2x1, then f of x2 is equals to 2x2, then f of x1 is equals to f of x2. That implies x1 is equals to x2 for every x1 and x2 are belongs to which one? Real number, because we have to consider the domain. X1 and X2 values are present in domain R. Again, for onto condition. For onto condition, we have taken as f of x is equals to 2x, then substitute f of x by y is equals to 2x, then taking as a y value, okay, x is equals to y by 2, okay, then whatever we have to substitute, okay, all the y values are present in codomain. Whatever we have substitute y value, then we will get a real number which is belongs to real number, because we have to substitute x is, again keep it as taken, y value becomes minus, y value becomes minus 1 minus 1 by 2. What is the value of minus 1 by 2? Taken minus as a common, 0.5. Okay. Then whatever the image, that is, we have to substitute y as a minus 1, then we get x as a minus 0.5. 0.5, okay, where it is lies, the point value is lies between here 0 and minus 1, because it contain minus the value which is present here, that is 0.5. okay, minus y has the image. Okay, then again we have consider y is equals to 1 by, we have to consider y is equals to 1 by 2. Okay, y is equals to 1 by 2 means 1 divided by 2, then again whole bracket here. Okay, by the condition the answer will be 1 by 4, because this will multiplied with here. Okay, 1 by 4, which is also real number. So 1 by 2, 1 by 2 has the image here. Okay, whatever the real numbers are taken as a y value, then must be x value will be exist. Whatever we have considered y, then x must be exist, and that x value becomes real number. Okay, therefore it is unto. Up to this is enough for examination. This concept I explain just for your understanding first. Okay, I will discuss this one while taking an example which is for your understanding. Okay, now discuss other than exercise examples and some examples in next session. Thank you.